also start recording. All right. So it will be great. We are just 4 people in the session, or 5 people actually. All right. So it'll be great if we could introduce each other, and I will unmute you for the introduction, and you can introduce yourself, and then you can mute yourself. All right. So let's start with Gridhar. Gridhar, can I unmute you? You want to introduce yourself? All right. Let me just unmute you. Yeah, go ahead, Gridhar.
Hello, I'm Giridhar. I live in Milwaukee, right next to Chicago area. I work in Oracle developer. As a Oracle developer, I used to be. I was working since 2001 here, and I'm planning to change my career into big data. That is the reason I joined this course.
Great. Great to know you, Gridhar. All right. How can I unmute you? So you want to introduce yourself? And Rahul, Shekhar, and Shrish, can I unmute you also afterwards? All right. Uh, how can I unmute you now? You want to introduce yourself? Okay. Looks like he is. All right. I have unmuted you. How? You can go ahead.
Hello, hi, this is Hao. Hi, I work for in software industry for more than 10 years. In last 5 years, I work in Java technologies. So right now I'm interested in big data, so this is why I take a course. Yeah, maybe my company will use big data in the near future, so this is why I take this course.
All right. All right. Great to know you. How?
Yeah.
All right.
Nice to meet you, Cindy.
Okay. Great to know you. How? And all right. All right. Let me unmute Rahul now. All right, Rahul. You go ahead. Looks like you are still muted. Yeah.
Hello. Hi.
Yeah.
My name is Rahul. I am an associate architect with Intro Technologies. We are currently building a platform over which we are highly in need of data. So I was analyzing various, and I had some introduction with Spark. Then I attended the introduction to Apache Spark. It was interesting, and the point that I wanted to be a part of a big data community where whenever problem arises or when people do something new, we would come to know about each other. So I thought I would join the course.
Awesome. Awesome. Great. Great to know you, Rahul.
Yeah, same here.
All right. Great. Okay, Shikhar, I'm going ahead and unmuting you.
Yeah, hi Sandeep. Hi others. I'm Shekhar. I'm from Pune. I'm working in an investment bank. A lot of projects are coming in our bank which are going to be based on big data. So
Mhm.
that's the reason I want to learn big data so that when they come in our bank, I should be able to support them in a proper way.
Great. Great. Great, Shikhar. Great to know you. All right. And all right, let me unmute Shrish now. All right, Shrish. Okay, go ahead, Shrish.
Yeah. Hi, this is Srish. I have close to 10-year experience in IT industry. Basically, I'm from RDBMS background. I'm a DBA
Awesome.
for around 9 years, 9.5 years. I work basically based on DB2 mainframes, Oracle, and different things like Linux environment. Basically, like why I'm interested in big data. Basically, like after after 9 years of my DBA career, like probably like I got a bit bored with this DBA. I just want to just do some kind of programming. So I was doing some kind of, I mean, like for myself for past 1.5 years. Then big data came in me at that time, so I got a bit interest towards that. So like just doing something myself. I mean, to know about it. That's it. So if I get a chance to move to that one, I will definitely consider.
Great, great. Nice to know you, Srish. All right, all right. So first we'll do a little recap. All right, we'll do a little recap. Uh, okay, and then we will go ahead with a little bit overview of HDFS, and then we will go over a quick overview over Yarn, and then we will go into the Python introduction, and then we will start with Spark. Is that okay with all of you? Okay, great, great. So this what we discussed yesterday, or in the first session number 1, we talked about why we need big data, and the most important aspect was the distributed architecture. Okay, distributed architecture, meaning instead of trying to improve a single computer, which anyway lots of people are trying to do every day for last 20 years, rather than just waiting for computer to improve, we are trying to utilize multiple computers to solve our problems. Tomorrow, even if the quantum computing comes into mainline, we can still use big data architectures, as in distributed architectures, and we will be able to utilize quantum computing in many ways as well. All right, so that's what we talked about, and we also talked about Spark in terms of velocity and variety. Variety for MLlib and variety will be tackled by tools like MLlib, GraphX, SparkR, while the velocity will be handled by Kafka and Spark Streaming. Okay, so those are the basic premise we had talked about earlier, and then we talked about various use cases of big data, and then we talked about a little bit about HDFS, what is HDFS, and then we talked about what was wrong with Hadoop MapReduce. Okay, Hadoop MapReduce basically for everything it would write to the disk, read from the disk. Okay, and that was the reason why it was slow. All right, that was the reason why it was slow. Then we talked about an ecosystem or the architecture of Spark in terms of this. Okay, you may not have seen this diagram earlier. Now here there is, you can see there is R, Java, Python, SQL. These are the languages with which the user will talk to all of these systems. All right. We talked about the core of Spark, which was RDD. Basically, RDD is a way of loading data into kind of in memory, partial in memory actually, not full, and then doing various kinds of operations on top of that. All right. Next is that we talked about quickly about various tools. What are those tools for? And then we basically went over the list of the tools which are there in Spark. All right. So in the getting started part, all right. So I'll just quickly go through the getting started part, and then all right, and Then we'll talk about HDFS and other components. All right. So to get started with Spark, you don't really need any other thing than the Spark. So all you need to do is just download Spark and get started. All right. For our case, because of CloudX Lab, our life is far more easier, and you can actually get started by just going to your account. Okay, and then my courses. After you click on my courses, you will come to this page. Okay, and there you will see the Spark page. Okay, not this one. This is the previous one. This one. All right. So everybody is able to see this page. Rahul, Shekhar, Gridhar, how, and Shirish. All right. All right. So are you able to log into the web console? All of you. You can just take the login. All right. So you can see that we are able to log in into our account. Good. Now here, if you want to run the console of Python, Python Spark, then you can run PySpark. All right. And then you can get started. Okay. So that's probably the quickest way to get started. You can press Control D. Okay, you can press Control D and exit this console. All right, this console can be exited after you type. So this is the way to get. Okay, or you can type exit and round brackets. All right, Rahul is saying I'm getting error. All right, I'm getting the credentials. Okay, okay. I will take a look at your account, Rahul. All right, I'll take a look at your account, Rahul. And okay, okay. Let me try to update your account. All right, all right. How is not able to see the page? No web console. Okay. So what kind of error are you getting? For Sekhar, the web console is working. Access denied. Okay. So do you see your login credentials here? These parts? How? What do you see here? Mm-hmm. All right. All right. I got your problem, Rahul. Okay. I will. All right. So, okay. Can you show the screenshot if you have how I can quickly see, or I can just make you a presenter for a minute and then we all can see your screen. Will that be okay? Because these are the minor issues I can handle. All right. Yeah. So I made you the presenter. How? Oh, you are not able to log in here. Oh, okay. Okay. I will have a look at it. How? No worries. All right. All right. I'll take a look at it. All right. Okay. Then I'll make myself presenter. I think looks like your login account. Maybe it's a different login which we are using, and that may be the problem. Okay. All right. So okay. What about Gridhar and Gridhar, Shrish, and so Shekhar is able to log in. Rahul is not able to log in. I get the problem with how I understood the problem. What about Gridhar and okay, Shrish is able to log in. All right, great. Anybody else left? Okay, I got the problem. Okay, so Rahul and Gridhar is able are getting the same problem. Okay, so I'll just take a look at your accounts, maybe during the break, and then you will be able to log in. All right, all right. Or I can freeze the screen for a minute and then take a look at your accounts, and that should be good. All right. We'll just do it in during the break. Okay. So with Sekhar, Rahul, and How. Good. I'll get it done. So is anybody missing? Sachin, are you able to log in? You haven't have your introduction yet, Sachin. Can I unmute you for a second and you introduce yourself? All right. Sachin, do you have a mic so that we can unmute you for a minute and then you can introduce yourself? All right. All right. So we'll have your introduction tomorrow then. All right. So there are few minor issues with the hands-on. We will do the hands-on again after the break, after I fix the problem with your accounts. And it's good that I'm coming to know about it immediately so that I'll try to solve it as soon as possible. All right. So a quick way of starting starting with Python, starting with Spark is using Python, and the easiest way is to basically log into the web console and type PySpark. And once you are inside the console, here you can start writing your Spark code. And whatever if you are writing something related to the Spark and then you're executing it, it will get done at Spark. It will get done at the cluster. Rest of the things will get done locally. All right. We will get into the details of exact semantics of how do you code for Spark. Okay. And once you are within it, if you want to exit, you can just press Control D and you can exit. Also, if you take a look at Python, the console is almost similar, just that banner is different. Same semantics as Python. So PySpark is nothing but a variation of Python which has two or more three more two three libraries more loaded into the console. All right. So when you want to get started, the easiest way to get started is you download the Spark. Okay. If you are, let's say, working for your organization, find out the version of Spark and then version of your cluster manager. So Spark can run by its own on your cluster manager, or if you have already if you already have a cluster manager such as Hadoop, you can download it. Okay. Say for example, we have 2.6 and later we can select this and we can direct download it and start the download. Okay. So it's pretty straightforward. And then once it's downloaded, you unzip it and then run bin/PySpark and it will run automatically. All right. We will go into more details slowly. We'll not jump into it just like that. Okay. All right. So, so do you want me to cover a bit of Spark and HDFS quickly? So, okay. So that was a quick recap. Let me start a bit with HDFS and Yarn, and then we can go ahead with a little bit about Python, and then we will start with actual Spark. All right? All right. So let's start with where is my. So I will pick my Hadoop usual classes. How many of you have done the Hadoop course earlier? Okay. Sachin has done. Good. Good. All right. All right. So good to know that, Sachin. All right. So we'll just quickly go over the HDFS. All right. All right. A quick question to all of you that if you have to store 100 terabyte of data, how would you if you want to store 100 terabyte of data, how would you store it? How will you build the architecture? Where will you store such kind of data? Anyone quickly? If you have 100 terabyte of data, how are you going to store it? Correct. Distribute among the multiple system. Shekhar says using some distributed file system. Good, good. All right. So let's try to see what we did traditionally. What we did traditionally is we took a lot of hard disk and assembled many computers, and or you can think of it this way, that we took many computers connected in the network and then we created these kind of folder structures such that each folder is mapping to a hard disk in the cluster. Okay, so that all the hard disks are available as folder. All right, so do you see any problems with this kind of architecture? All right. Also, please note that in our sessions, mostly you have to interact a little bit more. So only then these sessions are successful. Otherwise, it becomes totally one way from me to you, and that doesn't generally work. All right. that's not generally fruitful. It's if it's only me continuously talking. Okay, so the only way to learn is by asking questions, and no question is dumb, no question is stupid, every question is correct. All right, so keep on asking as many questions as possible, because the chances are, if you have that question, chances are the other people are also having the same question. It is just that they are not asking. All right. So my question is that, let's say we assemble a lot of computers, connected them into network, and then in the network we map the drives such that we have on one computer we have this main folder, and there is a folder for each drive. There is a folder for each drive. So, do you see any problem with this kind of system, this kind of architecture? Yes, Shekhar, Rahul, Sanjay, Srish, Gridhar, how? Correct. It's a single point of failure. Unindexed data, that's correct, because it'll be very difficult to figure out where is my file. Brilliant. Any other? So we have basically connected these drives such that they look like a folder under our main folder. All right, no worries. So here, there were challenges with those systems. First, if one of the hard disks goes down, all the data goes down. Even if we have RAID on each of these machines, RAID as in every disk is backed up on the same hardware. Still, if the network cable is plugged out or something wrong happens, the whole hard disk and its backup will not be available. So you do have backups, but there is no failover. Second, how about how would you distribute data uniformly? How would you decide which data goes into which drive? Next, is this the best value for money? You may have already many hard disks lying around of a smaller capacity. So, is this the best value of money and resources? Next question is, what about accessibility? Let's say there are five people who want to watch the same movie. Now, one single computer will not be able to cater to all five people simultaneously. Correct? Next is scaling out. Today, you wanted 100 terabyte storage. Tomorrow, you might want 150 terabyte of storage. So, is it possible without too much of architectural change to introduce 50 more terabyte storage in this? Okay, so that is scalability. So answer to these questions was very tough and was not possible using traditional architectures. And that's where that's where the new generation or distributed file system comes into play. Okay, so all of these problems what we have just discussed are very well solved by HDFS. Okay, so HDFS is So one of the points raised by I think Rahul, that what about the indexing? Okay, the unindexed data. That's a very good point. We need to know which file is where when you have too many hard disks. And that's what is done by name node. So HDFS is made up of two kinds of nodes. One which is singular, the kind of king, and then many nodes. Okay, the single one which is called name node, and many ones are called data node. So every machine on your cluster, you make it as data node, and only one machine you mark it as name node. So name node keeps track of what is where, while data node do not even know what is the actual name of the file. They only know a big number that represents the data. Okay, so name node keeps the metadata. Metadata means the information about data. What is where? Which file has got what folder name, and all the folder structure is basically stored in name node. Okay, data node does not know anything about folder structure or file name. All it knows about the actual data inside the file. All right, so name node is basically name node is basically a metadata storage and kind of the master for all these data nodes. And all of these things, whether I call it name node or data node, they are not special hardware. Neither they are special operating systems. They are basically processes. Like you have email server, you have web server, you have all these kinds of servers, right? And these servers can run anywhere. Similarly, name node is just one server which is running at a particular port. Data node is one server which is running at a particular port. Okay, server as in a service listening on a particular port. And in the networking, when the way we communicate to the process is by connecting to a particular port, and that port is what it has blocked. Port has been blocked by that particular service. For example, if a web server is running, it it is listening on a port called 80. So when you type in browser www.google.com, by default it talks to 80 port. Or if you are typing https colon google.com, then it is talking to google.com server and talking to 443 port. Okay, so that's how the HDFS work. So that's how a process works. And the name node and data node both are a process listening on various ports. Next is the data is sliced into pieces. Okay, why? Because very big file can fit into smaller disks. Data is distributed uniformly. Okay, it helps with basically it leaves less unused space on the disk. If you remember correct, if you have been um, somebody who used to organize his movies and songs, and at least I did face this problem. So we'll split our hard disk into C colon, D colon, E colon, F colon, and then we will put some data in D, and then we'll try to fit more, and then we will realize that okay, so the D colon is full in the sense that we are not able to fit another movie, although it has got 800 MB space, but our movie is 1 gigabyte. And in 800 MB space, we could have fit in lot of music, but the music we had already decided to put in E colon. So these kind of distribution of data problem keep on occurring all the time. When you create these independent island kind of things, you always are in the trouble of of trying to fit in the data. And that's where slicing big files into smaller blocks makes sense. All right. Next is it optimizes transfer. If you have one file broken down into 5 blocks, and these 5 blocks are existing on 5 different computers, so what would happen is when that means 5 people can access this file parallelly, just that they'll will be if they have a difference such that first person reads the first block which is located on one machine, first machine, and second person reads the second block which is on second machine, and so on. So it is possible to have 5 concurrent readers on the same file if there are 5 blocks. So that's how it these blocks helps a lot. Second, it helps in the rebalancing. It helps in the rebalancing in the sense that if we are deleting one storage, so we could move some blocks to one machine, some blocks to another, and so on. So it basically optimizes the data transfer. Next is it distributes the load to multiple machines, which we have already discussed. All right. All right. So questions related to name node being the bottleneck, I will take up after this. All right. A quick question again. A quick question again here. The the data which is in the blocks. So each block, let us say you have 200 MB file. Okay, 200 MB file. By default, in the cluster which we are using, it has got 128 MB. All right. My question to all of you is, how many blocks are there for 200 MB file? Quickly. Correct. Two blocks. One is 128 MB, and second is the 72 MB. Okay. Okay. So this is what it will have. Okay. Two blocks. I'll say two blocks. 128 MB and 72 MB. So if you go into a data node machine and you try to try to look into the folder where it stores the data, you will find these two files. On one data node, you will have to find out which all data node your file has been stored. Okay, and there on one you will find 128 MB block file, and on second you will find 72 MB file. Now all of this is generally hidden from you. Okay, these are internals of HDFS. Yeah, go ahead, Sekhar. Question from Sekhar is, for second block, by default it would create 128 MB block. So 128 minus this would be free space in it. No. So it does not. So basically, that's what I was trying to explain. So when you create a file which is of 72 MB size, does it consume 72 MB or does it consume more than 72 MB on the disk? If you create a file that's of 72 MB, does it create more space than 72 MB or just 72 MB? That's right. So that's why it does not put any padding. It does not put any extra storage. It will consume only 72 MB. Okay, it won't consume 128 MB. All right. So generally what happens is when you are building a database, okay, when you're building a database and you're expecting that there might be updates in each record, right? So what you do is for each record, you leave padding in the disk. Okay, so that when if somebody updates a particular record, you can consume the space which you had left earlier instead of moving this record into a different disk space, right? So those are the problems which are handled by other kind of system, but here it's a file system. It's a file system, and in file system we don't need to put padding. All right, clear to everyone? So the second block will be of 72 MB size, and that's the amount of space it will consume from the disk. All right. Next is every block gets replicated. Every block gets replicated on, and the default number of copies are 3. So this 200 MB file will actually consume 600 MB storage. If you upload a file, you will see that right now our cluster shows that there is 1.1 terabyte space. But the moment you upload for 350 MB file, it will actually consume all of the disk space left. All right. So the actual disk space left, if you think about replication factor, is around 350 MB, because 350 into 3 will consume all of the disk space available as of now. All right. So next is that you cannot have replication factor more than number of nodes you have. If right now we have 6 nodes in the cluster, if you try to create a file with a replication factor of 7, it will say that it is not healthy. It will show you that it is below the under replicated. Okay? So basically all I'm trying to say is it never keeps 2 copies of the data on the same machine. All right? Now if a data node fails, so when the data node fails, all the blocks on that machine are gone. With- But good news is that there are 2 copies left for all the files that have been lost. Okay? Although in case you made a mistake and you forcefully set the replication factor of each file to 1, then your data is gone. If you had set the replication factor more than 1, then you will have another copy available, right, of all the data that is lost because of the loss of one data node, right? So if one data node is down or gone, so all the blocks which were on that machine, all those nodes, replication has gone down by 1. So if they had 3 copies, 1 is gone, 2 is left, 2 are left. Now immediately name node will inform these nodes which have the copies available with them to start replicating them and bring the replication factor again to the one which is promised. By default, a promised replication factor is 3. If somebody wanted 4, you can set 4 for the file. Okay, so that's how the replication works. All right, so Rahul, that answers your question. So Shree's question is, what is the ideal replication factor in most systems? Okay, in most systems, the ideal replication factor would be 3. And you would ask, why 3? Why not 2? Okay, why 3? Why not 2? So first, in our normal systems, we used to keep a replication factor of 2. But HDFS is very risky. Ask how. Why is HDFS risky? Imagine there is one particular file, or there are say 10 files, really big files, and these 10 files each have been broken down into, say, let's say you have 10 files and you have 3 nodes, and all 10 files have one block on this particular node called data node 1. One block of all these 10 files is on data node 1. If data node 1 goes down, if data node 1 goes down, the block is gone. Okay, the block is gone, and that kind of loss impacts all the 10 files. It does not impact only few files. It impacts probably the whole file system. So and therefore HDFS is riskier than the normal file systems. That is why you generally keep a bigger replication factor. Bigger replication factor as in more number of copies, and therefore the replication factor of 3 is okay. All right. So we do not want to take a slightest chance. There are many kind of possibilities that are there, and hence having a situation where two nodes have gone down is very common. All right, Shrish, does it make sense to you? All right, so that was a quick review of HDFS. Now, next question is the bottleneck part. Bottleneck part is that first, this picture which you already have of the name node, take it out. Instead, think it like this. Okay, so when a client needs to read data, it reads data from directly from data node. Okay, it does not read data through the name node. It does not need read data through the name node. So you ask to download a file, when you ask to download a file from the name node, okay, so your client driver goes to the name node, client or the driver, whatever you want to call it. It's basically driver who basically does everything on your behalf. Whatever I'm going to talk about, everything is coded in the client slash driver. So this driver has all this logic built in. Okay, so the driver goes to the name node that, hey, my user wants this particular file. Now name node says, okay, fine, yes, I do have this file. Why don't you go to these data nodes and download the data from there? Do not bother me. Okay, so the driver understands the language of name node and goes to the data node and downloads the data from multiple data nodes and combine them together and gives it to the end user. All right, so that's the role played by the client driver, and you can see that name node tries to avoid becoming bottleneck as much as it can. It tries to delegate lot of work to data node or the client driver. All right, now the next question was that what if this name node looks like a single point of failure, right? So one is you keep the backup of name node's space image and edit log on two locations. This is a this is a feature of HDFS. This is a feature of name node that you can configure name node to keep the copies of the whole metadata image as well as the transaction logs, because periodically periodically name node keeps on saving the whole metadata image into the disk, and continuously if it keeps writing the edit logs. You can configure it to keep it at two different places so that in case something goes wrong with it, you have a copy of the metadata, you can manually bring it up. All right, and next is you could even have a secondary name node which is having all of this data and is ready, kind of you can make it ready to serve. All right, but the best way to do is using the high availability feature of name node. What does it mean by high availability? High availability means that as soon as name node will go down, there will be another node which can replace name node. So there'll be a standby of name node waiting to serve in place of name node. Okay, so this is for very quick action, and this is good in case name node goes down at any point of time. Immediately, standby will get into the action. All right. All right. Now, question from Sri's is whether any manual intervention is required to bring up the standby. No, you don't need to. Okay, so standby automatically comes into the action. And how does it work? The client driver does the heavyweight lifting. Client driver has the name of both the nodes, name node and standby. And client driver does this resolution to figure out who is name node. Okay, so that's the role of standby. I think we have standby in our cluster. All right. Sometimes this is something. There is a feature called HDFS federation. What does it mean? So if you had noticed here, so far we talked about all the metadata we keep it in name node. Okay. So standby here is just the mirror. What if there is such a big file system that the RAM of name node is full and you are not able to increase the RAM of the name node. Okay, in those cases we cannot afford such kind of system, right? If name node's memory is full, what could we do other than increasing the RAM, right? And that's where the federation model came into play. Okay, federation model makes it possible to have multiple name nodes serving different folder structure. So, for example, you could configure such that you could configure client library that the slash my data request for any data within slash my data top folder will go to name node 1, while rest of the queries will go to name node 2. Okay, so you can keep a mount tables the mount tables with the client library so that the work of name node is divided into multiple name nodes. Although please note that both the name nodes will use the same pool of data nodes. Okay, they will use the same pool of data nodes. All right. So that was our HDFS. Any questions at this point? Okay. What does it mean? Arpan's question is, what does it mean by pool of data nodes? Okay. What does it mean by pool of data nodes? Pool of data nodes means mm, basically it's the same list of data nodes. So the way we have 6 data nodes right now, right? That means the same 6 data nodes will be utilized by both name nodes. Yes, that's correct, Shekhar. So it's just metadata that's divided amongst name node in the federation. Okay, Arpan's question is how to configure the directories for name node. The directories are configured as part of something called mount tables. This information is stored with the client library. We create a etc configuration file. In that, we put the mount tables and client library would read from there. All right, brilliant questions. So that's how the HDFS works. All right. Any questions at this point? Okay. Some sample of HDFS. I'll just show you. Okay. So there is a command I would like to show you. All right. And I think somebody has kept the data somewhere. All right. Did I keep some data somewhere? Let me open Hue. Let me open Hue. All right. So after I log in, provide my login password, it will log in, and you go into file browser. There you will see the HDFS. Okay. And for each of the files, you can see that the data is for each of these files, the data is located in two data nodes. Okay. This data, can anybody tell me when I open this file browser and this list comes in, are we okay? Or let me ask another question. When we say Hadoop fs minus ls, so this is the way we can actually query HDFS, or we could open this folder here. Okay. Okay. Do we talk to HDFS or sorry, HDFS name node or data node? Brilliant, brilliant. Yes, Shrish and Sekhar and Sachin, we basically talk to the name node. Okay, we only talk to the name node. Reason being, we are only querying the file names and this information. Okay, now when I say Hadoop fs minus cat my file, cat basically prints whatever is there inside my file onto my screen. It reads the data from my file and puts it onto my screen. So when I say this, okay, do we talk to the HDFS name node or data node? All right, that's correct. How you are right. Okay, or both. Yes, we talk to name node and data node both. That's brilliant. Shekhar, Shrish, and Rahul and how. That's brilliant. Good. Great. So you all got the hang of it. Now let's try to see where are the blocks. Okay. And I think I had uploaded one folder with a really big file. All right. Looks like I haven't. All right. Let's just pick this file and check. Pick this file and check the details. All right. So what is the name of the folder? Name of the folder is this. And what is the file that we want to copy or we want to inquire? Okay, let's take data time zone tweets raw. Okay, tweets raw is little big folder, so that's the reason why I'm choosing it. Okay. All right. So this is our file name. All right. If you want to see the details about this file name, what we can do is we could go to we could use another command called hdfs, and we could do fsck and then dash blocks, dash location and rex. Okay, so let's go to the console. Let's go to the console here. Okay, let's go to the console, enter login, and also note that when you are typing the password here, sometimes clipboard copy to the clipboard may not work. So in that case, you might have to type. Second, when you type any password, it doesn't show anything. Okay, all right. So you can see that we are doing HDFS FSCK. It says that the file does not exist because we are looking probably in the wrong folder, right? Here, this is the folder. Okay, the folder name is this. All right, all right. So we go into the terminal. It shows that this particular file is healthy. The average block replication is this much. Default block replication factor is this much. Number of data nodes we have is 5. And right now we have only one rack. Alright. Next, what we want to do here is, alright. So other thing you should notice is that this particular file is located on these particular nodes. It shows clearly that replication factor is 3. You can see here replication factor is 3, and these are the nodes: default rack, then IP address, and this is the port, default rack, IP address, and the port. And this is where these are the data nodes on which our file exists. Okay, does it sound good to you? Alright, a common question from everyone is, what is a rack? Alright, can anybody answer the question? So I'll try to describe it. A data center keeps computers inside racks. Okay, a rack is an almirah, and this almirah has something called a hub. Okay, so all of the computer inside a rack are connected together via a hub, which means that they will be able to communicate with each other in really fast manner. Okay, these computers which are connected to this hub or kept inside hub, they will be able to communicate with each other really quickly. Okay, so that is something which is decided in the data center. Okay, so if your in your data center, if your data is on a computer of the same rank or same rack, that means the data transfer amongst them will be really fast. And these operating system, the new kind of operating systems, like not operating system, but new kind of softwares, whether it's MongoDB or Hadoop, they all are rack aware system. What does it mean by rack aware? Rack aware means Rack-aware means that they know that this computer is on this rack and that computer is on that rack. For example, when we try to store a file, the first copy of the block generally goes onto the same node from which we are uploading file. from which we are executing this command called Hadoop fs minus copy from local. That that node will be the first holder of the HDFS block. The node, data node that exists on that particular machine will contain the first copy. Second copy will go to the another computer in the same rack, and third copy will be on some computer which is not on this rack. Okay, so most of these softwares are rack aware. All right, good answer from Sachin. Rack is a hardware arrangement that manages power and network and hosts on the hardware. All right, good answer. Arpan's point is many times we hear about rack awareness when we talk about HDFS. What is rack awareness and switch? So you got the answer. This one in terms of HDFS. What does it mean by rack awareness? And related to the switch, switch is basically either a hub or a switch which we connect to the same rack so that these computers can talk to each other quickly. All right. The next question from Arpan is Blade server same as rack? No. Blade server is a machine which is basically very high-end machine. All right. For that matter, the the three we have three gateways for Amazon, and those three are based on the Blade server. All right, great, good. Uh, All right, great set of questions. All right, so the other plan which we had is basically a quick recap. This is done. HDFS is done. Now we want to dive into yarn. I hope that's okay with everybody. All right. All right. Because these things will be used again and again when we talk about Spark. All right. So the plan for today is that we finish yarn and then we talk about Spark plus yarn, and then we'll talk about Python and Spark maybe from the next session onwards. All right? Good, good. So here we go. All right. All right. Let's take a few steps backwards and talk about the first version of Hadoop, Hadoop 1.0. What was there in that Hadoop 1.0? The computational platform. Computation could be of anything. You might want to just go through this data which is lying in HDFS, or you may want to download a lot of data from internet by using many computers, or you have an encrypted password and you are trying to brute force it. So that could also be one of the cases. So there could be many computational examples, and most of them will either lie in velocity, value, volume, or the variety kind of problems. Okay? And in most of the cases, when you get stuck with the computation, and and you are not able to get the results in time using any of these systems, then you generally resort to a distributed mechanism, meaning multiple computers connected together to achieve the same goal, right? So MapReduce was the first step towards it. So the way it worked was there was a job tracker and there was a task tracker. So job tracker would only order things to the task tracker, and task tracker will do the the actual work. Okay? The end user always talks to the job tracker and asks for the status all the time. And job tracker would get the work done by the task trackers. Task trackers were the main workers. Okay? This job tracker will keep on querying the task trackers and find out whether this task tracker is up or down. If it is down, the work given to that task tracker would be reassigned to somebody else. That work will be reassigned to somebody else, and that somebody else would be another task tracker. So this was the model in MapReduce 1.0. So the irony was that both this kind of work, getting the work done kind of work, as well as the actual platform of MapReduce, where maps and reduces will be executed, data will be sorted, and all that will happen. That and this assignment part, resource management part, and actual computation part, both were part of same component called MapReduce. Both were part of same component called MapReduce, and in case one component goes down, sorry, so since there was only one thing called MapReduce 1.0, there was no separation. So it was like a monolith. You could only do the computation on Hadoop using MapReduce. That's all. You could not do the computation using Hadoop by any other means. And that's when some people, so this was the model earlier. Clients will talk to job tracker will assign the work to task tracker will create many tasks. And once tasks are finished, the work goes back to the client after all the tasks have finished. Okay, so this was not a great model. This was not a great model. And so one guy called Arun Murthy and few more decided to break it. Decided that the part which does the assignment, reassignment kind of thing, and the part which takes care of these resources, whether task tracker 1 is up, task tracker 2 is down, and which one is more powerful, task tracker 1 or task tracker 2, and so on. There were so many complications in execution, whether this task need to be long running or short running, and how it has to be executed. So there were so many work related to the resource management. So they took out the portions of resource management and they created a separate component called yarn. Yarn basically takes care of all of this assignment, reassignment, keeping track of who is free, who is busy, who is, and all that kind of work. So Yarn absorbed the complexity of doing the actual execution, while MapReduce stayed focused on doing the sorting of the data, ordering of the data. MapReduce is nothing but a huge mammoth mm, in, mm, mm, MapReduce is nothing but a big program which does the data sorting based on maps and reduces. Okay, I mean, it does a data sorting, and to control it, you write code. To tell this MapReduce program to sort based on a particular key, you write that logic is part of map, and how to aggregate the data that's written in the reduce. So the only way of computation earlier was in the form of these map and reduce. And map and reduces are more like a big group by clause that group my data by this key and then aggregate my values using this function. That was the MapReduce. Okay, if you think about it, the map function decides on what basis that the data need to be grouped, right? And reduce decides how those values are going to be aggregated. So MapReduce was more like a beautiful group by clause provided to you, and it gives you flexibility of defining anything as the key on which data could be grouped. All right, so coming back to it, so earlier MapReduce was doing both the things, and that's what was done in Hadoop 2.0. Yarn was taken out from MapReduce, and MapReduce was left just a computational way or computational paradigm. Okay, it is a computational way, and that made a space for all other different kind of processing, long running processing, short running processing, and whatnot. And if you see today there's so many new frameworks have come in. So MapReduce is not the only way of doing the distributed computing. There are many things that are done to do the distributed computing. MapReduce is just one. And that opened the door for so much innovation that today we have Spark on top of Yarn. Okay, so HBase runs inside Yarn, and and all of these systems are running inside Yarn, and Yarn is keeping track of who is busy and who is free. All right. So generally, there has to be a singular system managing your cluster. Only then you will have a clear picture of what's going on in my cluster rather than half picture. Okay. So you can see that it opened the door for all these aspects. All right. So Yarn supports workload other than MapReduce. It is done for scalability. It provides a complete compatibility for MapReduce. The old MapReduce and the new MapReduce remain same. The API remains same. The code which was written for Hadoop 1.0 still runs with the new MapReduce 2.0. It runs perfectly fine. There is no issue at all. And that is the thing, Yarn guys did a lot of good work. Okay, so it provides agility. MapReduce was a framework which was very batch oriented. There were need of other similar frameworks. All right, so what became what? So MapReduce 1 became MapReduce 2 plus Yarn. Job tracker became resource manager plus application master plus something called timeline server. While Task Tracker became Node Manager, Slot or Task became the container. Alright, I will show you what happens here. This is very important. All of you should pay a little attention to it. Arpan's question is, many of the distributed apps are being fit on the Yarn using Apache slider. That's correct. That's correct. We will talk about it briefly. Okay. All right. So as you can see that the job manager or job tracker became resource manager. The client comes to resource manager to get its work done. And it keeps so now each of these nodes became like state of the country, state 1, state 2, state 3, and he is the president of the country. Okay, the resource manager keep track of these the state managers like node managers. They node manager knows complete detail about the node. Okay, at every point. So resource manager talks to the node manager and keep track of what's going on. All right. Now, when MapReduce comes to resource manager that hey, I have got some work to do, then the first thing resource manager do is it creates MapReduce master or application master for each application. Okay, this master is the master only for the MapReduce kind of work. And this application master would go to the resource manager and say that, hey, I have got a lot of work to do. Can you give me 10, 15 containers? And he'll say, okay, fine. You, um, after consulting with node manager, resource manager will get back to application master and say that these are the containers in which you can execute something, and then they can get their work done inside the containers. So the client submits the app, resource manager launches the application master inside a container. Note that application master is also running as a container task. And then application master registers with resource manager, say, so that clients can connect to it. An application manager asks for container. The application manager asks for containers further. Okay. Application manager say that, okay, I need to churn around 2 terabyte of data. That means I need around 50 containers. Okay. Okay. So application inside container talks back to the application master. Client talks to the application master for the status, and on complete, application master deregisters itself from resource manager and shuts down happily. All right. Now the application client, okay, submits yarn application to the resource manager. Okay. It could be you, or when we ran PySpark, then that machine was the application client. So it goes to the resource manager and say, hey, I want to run Spark. Okay. So resource manager says, okay, fine, give me the code of Spark application master, and I will execute it inside a container. So resource manager talks to one of the node managers and asks for a container, and inside that container it runs the application master. So Spark master would be running inside a container on one of the nodes. And then application master again goes to this resource manager and tells, hey, I want I want 50 more containers. Okay. And then it starts creating container for its work. All right. So whenever whether the client or the application master, whenever they are asking for resource, they might ask for that, I need these many containers, this much memory, and this much CPU or processor, along with the locality constraint, saying the locality constraint means a request saying, hey, can you give me the containers which are closer to this particular file in HDFS. So that kind of magic is very well done by Yarn. Yarn talks to the resource manager, talks to the HDFS and finds out the information about each of the file which we want a locality constraint on. All right. Also, a resource request could be upfront or it could be as you go. All right. So a resource request could be, hey, give me these resources now. Or a request could be that, hey, I need this resource as I go. I don't know right now how many containers I would need, but just bear with me as and when we will have more and more data, I'll need to create more and more container. Okay, so that's could be as you go, or it could be upfront. Say, give me right away 20 containers. All right, that is the kind of request everybody makes to the resource manager. All right, so the application lifespan could vary too dramatically. For example, HBase keeps running lifelong, while a MapReduce job could end quickly in like 10-15 seconds. So lifespan is defined in three categories. One, simplest case, one application per user job. Second, one application per workflow or user session. So this application will not die unless the work is finished, unless the okay, unless the session ends. Okay. The third is long running applications such as Apache Slider or HBase. They are always on kind of systems. All right. So if you are inclined to create your own yarn application like MapReduce or Spark, you first try to use existing frameworks such as MapReduce or Spark. Second, try to utilize existing tools to build jobs. Okay, for example, you could use Apache Slider, which makes it possible to run existing tools inside the distributed in so you could use Apache Slider or Apache Twill to convert to basically put some logic inside the yarn application. Okay, so you could actually utilize the existing tool to build jobs, or you can build a tool from the scratch. Okay, but that's complex. Okay, so you can have a look at the source code of distributed shell application. It's actually very well done example. You should take a look at it to understand how to create your own new yarn application. All right. Now, next question from all right. Next question from Srish is whether yarn only runs on one system. How does it manage to run efficiently when more nodes are getting added? Because it has to manage more nodes. It generally happen with typical Oracle RAC. How does Yarn differs from it? Okay, so one of the important things of Yarn is that the nodes such as resource managers actually delegate all of the work to others. Okay, so the what you call resource manager of Yarn basically gives work to others. All right. Okay, so it tries to keep itself free, but sometimes it might get overloaded. But it tries to keep on delegating all of its work to others. Okay, that's the one big difference. Okay, next question from Arpan is, could you please explain the initial flow, how Spark app will start? Okay, so I'll explain to you. So this is basically, if you think about it, this is what Apache Spark starts. So Apache Spark would start and will talk to the resource manager. Okay, and when resource manager for each Apache Spark instance, it might create one. It basically whenever you launch it, if there is already a there is already an application master running for Spark, it will use that one, or it will go to the another one and create a fresh new application master, and then it will continue. All right, so we will come back to this point again and again. All right, we'll come back to this point again and again, so stay tuned. All right. All right, the diagram on slide number 40. Yes, that's right. Now, question is very good question from Rahul. Can I use Spark with HDFS without Yarn? If no, then if I'm using a data store like Cassandra instead of HDFS, then is Yarn still required? So first, this one, yes, you can do. Okay, yes, you can do. And as well, when you're reading data from Cassandra, it will definitely try to figure out where are the parts of data. Okay, and it will also help you such that you get the nodes which are closer to the data. All right, so definitely you can use HDFS without Yarn. Okay, but if you are using with Yarn, you will get the resource locality optimization. Okay, file HDFS locality optimization. All right, a question from Srish. What is a container? Container is the actual boundary here. Okay, container is the actual boundary inside which something runs. For example, application master is running inside a container. Similarly, the actual work when MapReduce runs its maps, it will be done inside the container. All right. All right. So Sekhar's question is, do we also have backup of resource manager just in case the RM fails? So resource manager is fairly stateless. Okay. Resource manager is fairly stateless. And therefore, there is not much of a need to keep the backup of resource manager. All right. Yes, that's a very good point. How? His point is that container is like JVM. Yes, it is a JVM. Yes, Sachin. Sachin's point is exactly same. So would JVM be the container or would you have multiple containers running within a JVM? So it's generally multiple containers, okay? Containers in a JVM. All right. So let's take a quick break for 10 minutes and back by 10 right now it's 10:10, so let's come by 10:21 p.m. IST. All right. So, hi everyone. Now I have enabled everyone's account, so you should be able to log in. Okay. So, for some reason, everybody's account has expired on the CloudX Lab. So, now it's all right and it should be working fine. All right. So, you can try it, and if you have any problem, let me know. Okay. So now everybody's account you will be able to log in into, and then can use that. All right. Good. Good. All right. So there were a few questions that I had to answer before the session, and I think my screen is still not working. So let me just resume the screen. All right. All right. So is everybody back? Should we start now? I know I'm around 5 minutes late. All right. So question from Sri is, so container is a range of memory blocks. Not really. Container is like a virtual machine which can run everything inside it, and container ensures that this program which is running inside the container does not cross its boundaries. Okay, so container also enforces the various kinds of security measures. All right. Does it make sense to you? All right. Now we were talking about this process. So that was a quick anatomy of yarn. That was a quick anatomy of yarn. Any questions on yarn? Anyone? Everyone actually? No questions? Arpan, Rahul, Sachin, Shekhar, Shrish, Valentin. So Valentin, since you have just joined, I was explaining the flow. So we did a little recap of what we have done so far. Then we talked about HDFS, which you have already attended. And then we talked a little bit about yarn. How does yarn work? And now we are going to discuss how does yarn work with Spark. Already? All right. And then uh, we will actually go over the basics of Python, which you have already gone through, and then we will dive deep into Spark and various libraries. Okay, all right. Rahul's next question is, what are the alternatives of yarn? What is it? Oh, why is it behaving so erratically? What are the equivalents of yarn? There are many equivalents of yarn. Okay. For example, there is something called mesos. There's something called there is a layer from Amazon EC2. All right. All right, so that was a quick overview of Spark. And all right, any questions at this point, or should we move ahead? All right, great. So Sachin is able to log in into Ambari, Hue, and the console. Great. All right. So before we start with Spark, in general, as a user, you generally download Spark and you figure out which one is compatible with your Hadoop and you download that one. Otherwise, you can actually happily download the standalone version as well. Okay. If you are on the server, you can use a wget command. And then once you have downloaded, you can just unzip the Spark tgz file and copy it to a place where everybody can access, for example, user lib, and then make a clean link such as user lib Spark. Okay, and you can download the Spark from their website after selecting the corresponding version. All right, so that was about downloading, which you don't need to do. Okay, all right, so a quick overview that this diagram shows that if you have 4 nodes in your cluster, your there'll be some whenever you try to load data into Spark, you would be creating something called resilient distributed dataset. We gave a quick overview last time. We will go into more detail into RDD and see how does it work. Okay, and again here also we are talking with from a very high level. All right, so the whole story at Spark starts with resilient distributed dataset. This dataset is basically either it's a list of commands, sometimes it's basically a pointer to begin with. So when we say my RDD is equal to load data from HDFS, so this RDD does not contain much of the data. Instead, it's a pointer to HDFS. Okay, it's a pointer to HDFS, and these pointers are created such that the nodes which contain the RDD are same as the node that contain the corresponding block of data, so that the communication between RDD and the HDFS data does not happen over the network. Okay, so the block that is existing in data node running on this node number 4, there'll be a pointer here to that. If there is a data node running on node number 3, there'll be a pointer to here, and so on. So this resilient distributed data set is basically the data spread or pointers spread across multiple systems. Now, to manipulate this data, you as the driver application, you will be launching various kinds of logic in the form of transformations and action on top of RDD. RDD is read only. Okay, so this is a very high level overview. So you will be launching this driver application. So when you run this Spark, you're basically starting this driver application. This driver application will be running on multiple nodes, node 1, node 2, node 3, node 4. And all this work will be happening these driver applications. Okay, and it will be talking to the RDD. All of these Spark applications will be talking to the RDD. Okay, so there are 2 parts to the application. One is called driver application and other is the Spark application. Spark application is being executed all across the cluster while Driver application is generally singular. All right. So there are two modes in which you can run Spark. First mode is standalone. Okay. Not really. This is wrong. And yeah. Okay. There are two modes of Spark. One is standalone and other is over the cluster. So if you already have a cluster manager such as Yarn or Mesos, you will go for over the cluster. Otherwise you will be using standalone version happily. Okay. This standalone way is quite straightforward. And what you do in this case is you basically install Spark on all nodes, inform all nodes about each other, launch, okay, launch launch the Spark on all nodes. The Spark will discover Spark nodes will discover each other. Okay. So basically standalone mode has a built-in resource manager. Okay. Spark has a built-in 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 resource manager. That means even if you do not have a resource manager, you can still happily use Spark over the whole cluster. All right. But in production environment, it makes sense to go with the resource manager, either Yarn or Mesos. A question from Arpan is, does this driver same as the master of Spark? Okay, good question. Okay, so just a second, I'll turn off. All right. All right. So does this driver same as application master of the Spark? So generally, the driver is running in the application master. That's a good point. All right. That's a good point. We will discuss it more now. All right. All right. So the model is, in case of standalone manager, okay, and it's okay actually. Yeah. So what happens in case of standalone? There is a node that contains the RDD and there is a driver application. So driver application launches the Spark application. Spark application keeps talking to RDD and it's running on a node. Okay. So that's the standalone mode. Okay. Now in the standalone mode, we can simply run this. Okay, we can test it. If you want to do that, you can basically download this particular, download the Spark and start testing it. Okay, so here is an example of running in the standalone mode. Okay, all right, going back here. Yeah, so how to select which one to use? Okay, how to select which one to use? We will, there is a command line called master. If you specify minus minus master local, then it will run on local instead of on the cluster. Okay, if you just force it that don't run on the cluster, run in the local machine, then you only have to do is minus minus master and local. While we are running whether Spark Summit or PySpark or whatever, all we have to do is minus minus master local. All right, let's try to see if it works or not. Okay, I'm not sure it will work because this jar file we have to specify. Okay, so we'll have to find out where is the this particular Spark example file. All right, so what we have to do, find slash minus name this and to tab null. All right, so it has found the data here. So you can see this is the jar file that contains the Spark examples. All right, what does it say? It says that this port is already in use. It says shutdown hook called. Yeah, so it has computed the value of pi. Okay, so the example has run successfully and it has computed the value of pi. I'll try to explain to you. If you are interested, I can explain how does it compute the value of pi. Okay, so this is the command that we are running right now on the cluster. Okay, so what does it do? It basically executes this particular jar file as the Spark job, and this is in Java. All right, so here we are saying this is my class entry point, which is my driver application, and this is the whole bundle of code, and I want to run it locally, and I want to run it with 10 machines. Okay, I want to run it in 10 iterations, I think. All right, so basically this program is computing the value of pi. Okay, how is it computing the value of pi? I'll try to explain. Okay, and what is the point of all of this? Okay, okay, so unlike the word count problem, here we are trying to do something different. Okay, something different as in computing the value of pi. What is the area of circle, everyone? Circle of radius 1 meter. Yeah, everyone, quickly. Yes, that's right. The area of the circle will be pi. Correct. Now we want to compute the value of pi. Okay, by computing the area of circle. So how do you compute the area of something without using the formula. How do you compute the area of something without using the formula? By counting number of dots that are that particular within that particular area. Okay, by computing by basically counting the number of dots. All right, that's what it does. All right, so what's happening is, by counting total number of squares inside this particular area. Okay, so I'll try to draw it if I can do that. All right, let's say there is this circle of which you are trying to count the area. Okay, so what you do is you start drawing very small, very small, what do you call, very small squares. Okay, you start counting very small squares inside here, and then basically what you do is you go from here to here and top to down and find out what are the squares which are inside the circle and what are the squares which are outside the circle. Okay, so since we know the area of this cube would be 1 square meter, right? Because sorry, to 4 square meter. We are talking about a radius. This is 1. Okay, so the area of the square will be 1 plus 1, 2, and 2 into 2, which is 4 meters square, right? So out of 4 square meters, if we remove all these elements, then we'll get the area of circle. All right, and that will be the value of pi. So it's very clear that out of 4 square meter we will remove certain parts. That means it will come closer to 3, right? It will be less than 4 and will be greater than 2. Okay, so that's what happens inside this code. So you keep going from here to here, marking the small uh, squares, and then count those squares and then do it. Okay, now this can be made parallel. You could do this parallelly by dividing the work onto multiple computers, dividing the work, saying that okay, let let first computer do this, and second computer do this, and third computer do this, and so on. Okay, we could divide the work like that, or we could even divide it such that let this strip be computed by one computer, this strip be computed by one computer, and so on. There are many ways to distribute the work. All right, if you want to see the exact code and you're interested in understanding how the how we computed the area of a circle using this, you can take a look at this. Okay, you can take a look at this particular approach. All right, this is an approximation. Is everybody with me? All right, so we divide the work and let individual computer work on it together to solve the problem. Okay, all right, great. All right, a quick overview of various commands. PySpark runs Python Spark interactive command line. Interactive means it can execute one expression at a time quickly. Okay, so and Spark shell basically runs Scala interactive command line. Spark class runs Java class standalone. Spark submit submits a jar or Python application for execution on cluster. Spark SQL runs Spark SQL interactive shell, and Spark R runs R on Spark. So for time being, since the the version which we are using right now, it doesn't have Spark with it, so we have installed Spark separately for you. Okay, if you are interested right now, what you can do is you can go to user and Spark, and then inside bin there will be Spark car. All right, if you are interested in, all right, so here we go. All right, looks a little ugly. All right, good. So only Rahul and How is with me. All right, you want me to repeat the way the value of pi is computed? Okay, Sachin is also good. Shrish is good. Rahul got it. Shekhar. Great. So everybody is okay with that. All right. Great. All right. Now, those were the overview of the binaries. And you can try all of these binaries, just enter into it, and then you can exit quickly if you don't want to use, by saying Control D, by pressing Control D. All right. So even on when you run Spark on any cluster manager or specifically in Yarn, there are two modes. Two modes as in run as Yarn client or Yarn cluster. Okay, so the difference in these two modes is that the difference lies in the way the driver or the launcher is executed. Okay, so if you want to run the driver or the launcher on the local machine, then you generally run it as dash dash master and yarn client. Also, please keep in mind that whenever you are running Spark code, you will have to configure your Hadoop directory, Hadoop config directory. You have to set a variable called conf underscore Hadoop underscore dir equals to etc Hadoop. Okay, and then you say minus minus master. Say if let's say you are running PySpark. Okay, so in that case you can simply say PySpark dash dash master space yarn dash client. Okay, so when you say this minus minus master yarn client, it means that you are interested in running the driver application on the machine on which you are standing right now. okay, on the machine on which you are executing the command. All right. Sometimes you want to run the driver itself inside application master. Okay. As the question uh, raised by Shrish, that where does the driver application run? It runs inside application master if you are running as yarn cluster. All right. So the launcher or the or the driver application can either run on the same machine from which you are executing a command, or it can run inside the application master. Okay. Also, very important part about running it inside application master is that your client can disconnect. The guy who executed the command and started it, he can exit and continue his work while Spark will continue to run in the background to solve the problem. Okay, so these are the two modes of Hadoop slash Yarn while running the. Okay, so this diagram shows that the resource manager, okay, so the driver application is running on the local machine. Okay, and this driver application is running on the same machine from which you started the work, and this driver application will talk to the resource manager and then get the Spark application running on every node. Okay, so the driver application is running outside Yarn right now on the machine where it was launched. So the downside of this kind of approach is that in case driver application fails, there is no backup. And this only works in the cases where driver application is something you do not want a heavy resilience. Okay, but in production environment, generally you run the driver application inside the yarn. All right. So driver application runs outside yarn on the machine from which it was launched. Okay. If the driver application shuts down, the process will get killed. Does not have resilience, but it's easier and quicker to run. All right. So this driver application, what is driver application? It is the one who is executing your Spark program. Okay. Right now, when we open the console, it's us who is talking to Spark and getting the work done. But in practice, we generally schedule a script. Okay, we schedule a script, and that script execution is the responsibility of driver application. Now driver application will talk to resource manager and get the Spark application installed on Spark application installed inside the cluster by the way of application master. All right, and on each machine, this is basically node manager, not application master here. All right. So basically, the driver application is okay. So driver application can also run inside the cluster. Right now, it's on the same machine where you started. So in case this machine goes down, this process will stop. All right. Now, if you want to run the yarn in client mode, all you have to do is export yarn conf directory etc hadoop conf generally, and hadoop conf directory. This is the etc hadoop, but you don't have to do it generally in our case because we have already set this. Okay. So you export these two directory, and Then while running the spark submit command, spark submit basically submits your jar file to the cluster. While running that, you could say minus minus master and yarn client. Okay, and you could also say how many number of executors you want and how much driver memory you want to dedicate. Okay, is it clear now? So yarn can run. Sorry, the Spark can run in two modes on yarn. Okay, one is that the driver application itself is inside the application master, which can run on the node of the cluster. All right. All right. Now, if if the driver application is also running inside, if the driver application is running inside the cluster, this is how it would look like. You will do the Spark Submit. Spark Submit will talk to the resource manager, and resource manager will start Spark applications everywhere and one driver application. Okay, so this is how the yarn cluster mode work. If at this point this machine on which Spark Summit was executed, if if it dies, then this driver application, Spark application, will continue to run happily. And this is the preferred way of running things which are long lasting. Okay, this is the preferred way of executing Spark if you want to keep running it in the background. All right. If you want to run the Spark in the cluster mode, all you have to do is after setting these two variables, you all have to do is master yarn dash cluster. Okay. Earlier it was yarn dash client, and that's how the whole mechanism of executing Spark command works on yarn or on offline. All right. So yes. Arpan's question is, in the diagram, it shows that application master on each node. That's wrong. Yes. So I'll get it corrected as I was telling you that it is basically node manager. Okay. Here, what we are calling as app master is basically node manager. All right. That's a good catch. I had told you already. Question from Shekhar is, in yarn cluster mode, so request goes to resource manager and from resource manager to the driver. Yes. All right. All right. Any questions at this point? So these are the things which we discussed. One, how to download and get started. What are the various binaries? And we understood two modes of running Spark. One was standalone, where we are not using any resource manager. Second, on the cluster. And running in the cluster comes in two forms. Running on the cluster could be on Mesos or on Yarn or something else. But on Yarn, there are two modes. One is Yarn client and Yarn cluster. The difference between the two is the way the driver application gets executed. Whether driver application is run on the local mode, okay, in that case, it's considered as Yarn client, okay. If the driver application is running inside the cluster, inside the application master. In that case, it's called yarn cluster, and that's generally preferred way of doing it in production because there is no need of executing it manually. Second, there is you will only get driver application running on the node which are not which are up and running, okay, which are up and running. In case it dies, it will be shifted to somewhere else. So there's a huge resilience. All right, there's a huge resilience. All right. So that was a quick discussion on how to run Spark on the yeah. All right. Okay. All right. Also, in this problem, as we keep on increasing the precision, okay, the time taken will keep on increasing. Now you can see that it's taking too much time now. If we keep on increasing number of squares, the total time taken will keep on increasing. I said 10,000 squares this time. All right. All right. I don't know how much time it's going to take. There's so many tasks in this. All right. I have pressed Control C, but it'll be fun to see how much time it takes on these many nodes. Good. All right. All right. So now we can start our discussion on Python. All right. Should we start now? All right. Great. All right. So it's going to be a very quick discussion. It's not going to be very detailed, and that should be good for this course. All right. Where is the introduction? All right, let's jump in. All right, there's a point from Rahul. His point is that, do we have any project that needs to be specifically done in Python? Cause because I'm planning to do it in Scala. Yes, you are most welcome, and I'll completely support you. All right, if you want to do it in Scala. All right, there'll be no Python specific project as part of this. All right. A quick question that why people use Python is one, software quality, and because Python code is probably the most readable code I have come across. All right. The reasoning is that it forces people to leave the tabs and avoids the curly brackets. Okay. That means the readability is good, and readability leads to reusability and maintainability. Also, it provides the constructs for object-oriented programming, as well as it provides the constructs for functional programming. All right. Second is the developer productivity. Since there are dynamic types, you do not have to type too much. It infers the data type from the actual data. Okay. So it keeps on inferring the data types all the time. The code size of Python is generally one-third or one-fifth of Java code. Now, when you have shorter code, it's basically means that you have less to type, less to debug, and less to maintain. Okay? When you have short code to work on. Third feature of Python is the program portability. It's the same program which can run on Windows, Linux, or Mac. And it supports libraries, standard libraries as in text, pattern matching, and everything. Okay. So, and it also provides third-party libraries like website construction. So you have Django, with which you can do the website, and for numeric computing, you have NumPy, SciPy, and for serial port access, you have library, and for game developer, you have GamePy. Okay, and NumPy, for example, is considered better than MATLAB in many cases. Okay, so basically, Python provides you a lot of libraries and lot of functionalities which you can use out of the box, and it has got simple syntax to use, and it's probably the easiest to learn. If you have not coded for quite some time, you should try out Python. The the work becomes fun. Okay, work becomes pleasure than the chore. All right. So the component integration is another good aspect of Python. You can invoke C++ libraries. It can be called from C++, can integrate with Java.NET COM and Silverlight, can interface with devices over serial ports, interact with other networks like SOAP, XML, and etc. Right. So basically, my personal reason is that active programming is more pleasure than the chore. That is the probably one of the reasons why I use Python extensively. All right. Is Python a scriptable language? is Python a scripting language? Okay. When we say Python, is it a scripting language? Yes. It's a general purpose programming language that blends procedural, functional, and object-oriented paradigms. All right. Now, what is the downside? The downside is the execution speed is lower than C, C++. Source code gets converted into bytecode, and that leads to faster that, and then it gets executed. So when you are executing Python code, it tries to convert it into bytecode and then execute it. But if you want performance, you can use PyPy compiler, which will compile your Python, and the speed up is close to 10 to 100 times. Okay. Who is using Python? Google, Netflix, YouTube, Intel, Dropbox, Raspberry Pi, Cisco, and lot of industrial companies are using the Python for various kinds of work. All right. There are many more success stories on their website. You can go through it. What can I do with Python? You can do a lot of work with Python. Systems programming, GUI, internet scripting, component integration. Internet scripting as in downloading data from internet and all that. And database programming and rapid prototyping. And other than that, SciPy and NumPy are a great scientific computing libraries. Also, you can do a lot more with Python. All right. For that matter, I'm using one library which generates everybody's certificate that is written in Python. All right. So, who is supporting and developing it? There is a Python Software Foundation. Okay. And PyCon, and then there is a so PyCon is the main force behind Python. All right. The technical strengths of Python are object-orientedness and functional. It provides both paradigms. Okay, we will take a look at few functional constructs, and you will understand the beauty of those constructs. It's free. You can copy, embed, and sell. It does not mean that it's not supported. Alright, it is portable to almost all the operating systems. It's powerful with these features like dynamic typing, automatic memory management, programming in the large support. Okay. Built-in object types, built-in tools, library utilities, and whatnot. It is mixable, easy to learn, easy to use. It was created by Guido van Rossum and it was released 15 years ago. The name of this was given after a Monty Python TV series, okay, because the author liked Monty Python. Alright, so if you are using Eclipse, you can use Python by downloading Eclipse. First you download Eclipse, and after that you could mention this particular repository and then use the PyDev. Okay, you can use PyDev easily from the Eclipse. Okay, follow these steps and you will be able to install PyDev and then you can start working on that. Okay, you can start working on that. It's quite quick to run Python code from within Eclipse. All right. The Python interpreter is probably one of the important aspects. So please use Python 2.7.8. Also, you don't need to install any of this. You don't need to install any of these things because Python is installed on the servers. So you can just simply say Python and you will have this. Also, you have VI here using which you can edit your code, as well as you have Nano here. That's another editor like VI. So to edit your code. All right. So you don't generally need to install any of this, and that's a very big advantage of CloudX Lab. Shishi's question is how JVM runs Python. Okay, so JVM can run anything. It can basically bundle it, and there are ways like Jython. Okay, there are ways using which you can actually execute Python program from within Java. Okay, there are bindings available. All right. So you can start experimenting with Python from here. Let's try to jump in. And this Python interpreter is probably the best way to learn. Do not get into the Eclipse way of doing things. Okay? I prefer the interpretive way of learning because it's very quick to test, good for writing things and learning, works like a shell or a command prompt for scripting needs, and very quick to automate. Okay, for quick automation, interpreter is good. Honestly, you can start using Python interpreter as if it's a calculator. So you can use complex things like okay, and then you can assign it to a variable and then use that variable again and again. So even if you are not a big Python fan, still you cannot deny that this is useful. All right. Now, so Python interpreter is quite easy to test and learn. Okay. So here is a good example of hello world. So you can simply say print hello world. Okay. This is probably the easiest hello world you must have written. All right. Now the Python program is composed of vocabulary and words. Okay, meaning the variables and the reserved keywords. A sentence structure is basically a single expression is called sentence, and story means a block. Okay, a block. So this is how a program would look like. This is basically called a short story or Python blocks. And there are these reserved keywords such as and, del, for, is, raise, this. These are the reserved keywords. So you cannot keep a variable name with these reserved keywords. Okay. So these are sentences or lines, which means a single expression, such as x equals to 2, x equals to x plus 2, and then print x. Okay. All right. So what is Python script then? Python script is basically all the things you do in the interactive, they'll be lost. So you don't have a track record of what you did. So you can basically keep all that expressions into a single file, and that will become your script. Okay. So you can execute your script by saying Python my script. Okay. Okay, so lots of programs are bigger. So you put all these commands in a single file and then you rename it to .py and it becomes your Python code. All right. Any questions at this point? All right. So in Python, all the steps are sequential from top to bottom, and the sequential steps means that one's first step will be run, then second, then third, then fourth. Okay, the program control flows top to down, but you can break that by putting conditions. Okay, so if you put a condition like x is lesser than 10, if yes, then do this, otherwise you carry on, then again you test it. That's what we are doing. So for x is equals to 15, what will you get here? Anybody, what will be the output for x equals to 15? For x equals to 15, what will be the output? Yes, no condition is satisfied, therefore it will be finished, that will be executed, right? All right, then you have repeated steps. Okay, so let's try to code a little bit. All right, all of you. So let's try to code a little bit. So x equals to 10. Okay, let's try to compute the salary. Okay, let's say somebody's salary is how much? Say 10 lakh. Okay, okay, 10 lakh. Now we can say if salary is greater than, or tax, let's say tax equals to 0, if salary is greater than say 9 lakh, 9 lakh, then tax equals to say 30% of the salary, right? Now you can see that what is the value of tax right now? Tax is 3 lakh. Sounds good? Yes. All right. Any questions at this point? All right. So that was a quick way of showing. Where did it go? All right. So you could do complex computations like this. Okay, you can do a complex computation like this easily using Python. All right, and all right, so let's continue our discussion. All right, so here is a good question from Sachin. His question is, if you change just salary variable value, would it reflect text value immediately being interpreted, or you will have to walk it all over again? So it will reflect immediately. Okay? You want to try it? I think you should give it a try. Okay? So if you say, okay, so do you mean to say if I say salary equal to 20, will text change? Is that what you meant? So we change salary to 10 rupees. So tax will still remain the same. Okay? You'll have to run it again. You'll have to run it again. Only then it will make sense. Okay? Also keep in mind, all of you, when you are writing Python code, make sure the indentation is correct. That is something I have also not mentioned anywhere in the initial slides, but keep in mind you'll have to have the indentation. All right. Great. So that's pretty much for today. We will continue our discussion in detail in the next session. All right. Bye bye. Have a great day. Bye, How. I hope you are liking the session. Bye, Arpan. Bye, Rahul. Bye, Sachin. Bye, Shekhar. Bye, Shrish. Okay. Okay. No worries. You can